Hi, and welcome to this recording of Beyond Postgres, Modernize Your Applications Anywhere with AlloyDB Omni. Some of you might already be experts in AlloyDB Omni, and you just want to learn what's next or what's new in Next 24. Some of you might have some experience with AlloyDB, but might be new to running AlloyDB on laptops or on servers in your data center. And some of you might have never heard of AlloyDB or our Google Cloud databases before. And that's okay, because I really want all of you to take something away from this talk today, where I'll go over what AlloyDB can do for your applications and your Postgres-based databases. My name is Bjorn Rost. I'm a product manager at Google Cloud. Whatever industry you work in, your users are demanding great customer experience that is fast, meaningful, insightful, and based on your data. And you're delivering these experiences through modernizing, innovating, and creating new applications for your users. And since behind virtually every application sits a database, that makes your users and your use cases our users as well. And when it comes to databases, Stack Overflow runs a survey every year where they ask professional database or professional developers which database is their favorite one, and which one they're using today and which one they plan to use in the next year. 49% of them said Postgres is their database of choice. We believe they choose Postgres not just because it is open source, easy to license, and friendly to install, but also because it has a rich history of decades of being used for mission-critical workloads among thousands of customers and thousands of users. Postgres has great capabilities for traditional relational data types, but it can also be extended to things like vector search, JSON documents, semi-structured things, and geospatial information. So if Postgres and open source databases are so popular, why are we not seeing more of them in the enterprise today? Well, we believe it's for three reasons. One is open source databases can lack some commercial grade capabilities in terms of scale and performance and manageability. Migrating legacy databases is complex, risky, and costly. And lastly, if you're migrating to open source and you're using open source technologies, you're likely also interested in finding a partner that you can reach out for support 24/7. So when Google Cloud created AlloyDB, we knew that we wanted to start with Postgres and really take all of the best things of Postgres, including the robustness, the data types, the rich drivers and connectivity options, tools, and then we would add Google's unique innovation in performance, in scalability, in ease of operations, and the ability to build amazing generative AI applications and also infuse machine learning into the way the product works. We knew that AlloyDB is going to be very important for customers on Google Cloud, but we also know that AlloyDB can power your workloads wherever they run. Now, that could be on-premises in your own data center, either because you haven't migrated to the cloud yet, or because you don't want to or can't migrate to the cloud, because you might have sovereignty and compliance requirements preventing you from doing so. You might already be working in one or more clouds in multi-cloud, and you're looking for a standard database to run across different clouds. Or you might be running workloads at the edge, whether that is a factory floor or a retail shop or restaurant, where you want to run local workloads that are resilient to internet outages and can run autonomously. That is why we built AlloyDB Omni. AlloyDB Omni is our downloadable, self-managed version of AlloyDB for Postgres that you can download and run on premises, on Google Cloud Platform, on Google Distributed Cloud, in hybrid multi-cloud environments, really anywhere you want. AlloyDB Omni scales further and faster than open source Postgres. It's easier to operate with autopilots, and it allows you to build amazing modern applications with real-time insights and analytical queries and generative AI. And all of this, no matter where you run it, is supported and backed by Google Cloud Customer Care. So it'll be no surprise to hear what customers and users are using AlloyDB Omni for. First, there's a cohort of users that use it as a better Postgres that scales further, is easier to operate, and is completely backed by Google Cloud Customer Care. It's basically an enterprise-grade flavor of Postgres. Second, there's users that are looking to migrate away from legacy databases that are hard to operate, that are costly in licenses, and that are also hard to staff for. And they're looking for databases that are open source compatible, but still meet the same enterprise-grade scale and capabilities. Lastly, there are developers out there just like you that are building modern applications based on generative AI, real-time insights, and they find that AlloyDB Omni and AlloyDB AI make it really, really easy and comfortable to build these applications. In the rest of the presentation, I'll go a little bit deeper into some of these features and use cases. First of all is performance. We ran TPCC-style benchmarks on our Google Bare Metal Solutions servers. Those are your standard servers and storages that you would also encounter on premises. We ran it with 16 vCPUs, and we found that AlloyDB is more than twice as fast as open source Postgres. And this gap in performance increases even more as we scale up in terms of vCPUs, because we removed a lot of bottlenecks in Postgres to make AlloyDB Omni scale to larger machine sizes. So you actually benefit from larger machine sizes and larger compute rather than just more memory. Second in performance, we also added the columnar engine as an analytics accelerator. The columnar engine is basically an in-memory region that has tables or single columns stored in a columnar format that is optimized for fast queries over large volumes of data or aggregations. It is completely transparent to Postgres syntax, so you don't have to actually adjust your syntax. The optimizer knows about which tables are available in the columnar engine, and it can choose to either execute completely in columnar, completely in row store, or a hybrid scan of the two. Together, the columnar engine accelerates analytical style queries up to 100 times faster. So you get the same results, just much, much faster, which is kind of the difference between dial-up and broadband. It's not just about downloading things faster, it just allows completely new use cases like streaming. After performance, we looked at what types of areas create support cases for our managed Postgres services, and what are the areas that administrators of Postgres databases are struggling with today. And first of all, we found that nobody wants to tune performance manually, especially if you have hundreds of thousands of databases to administer. So when we built the columnar engine, we also built a job that can automatically populate the columnar engine based on your schema, your data, and the queries you run. And similarly, there's an index advisor that looks at your schema, your data, your queries, and it will recommend which traditional B-tree indexes you should build to accelerate your workloads. Postgres already has an auto vacuum process that is responsible for cleaning up old blocks that can be recycled and reused. And typically you would set this auto vacuum to a certain resource consumption or to a certain aggressiveness. We've made this vacuum process adaptive so that when your system is under high load and you are not too far behind with your auto vacuum, you will actually reduce the aggressiveness of the vacuum job to return the maximum amount of resources back to your user processes. And then later, maybe your load is a little bit lower, you will increase the aggressiveness again to catch back up with vacuuming, to optimize the amount of compute resources that are available to your workload and not your background workers. And then memory management, adaptive memory management is probably my favorite feature that I want to talk about in a little bit more detail. So in Postgres, there's a parameter called shared buffers, which is responsible for setting the amount of memory that is available to the database instance for caching, but also for operating on all of your queries. So every time you insert a row, it actually creates a block in the buffer cache. Every time you read it or you run a query and you read data, it has to be read from disk into the buffer cache and then operated on. So the more buffer cache you have, the less your system has to reach out to other caches or disk systems to read things, and the faster it'll run. If you set your buffer caches too small, you risk wasting memory and you risk wasting performance. On the other hand, though, if you set your shared buffers too high, there is a risk that you might run out of system memory, which is needed by background processes and the processes that do your actual work. which can scale up and down depending on your workload and the number of connections. The worst case scenario is that you run out of system memory, your background worker gets killed, and it can actually kill and crash your whole database, which is called an out-of-memory error, or OOM for short. In AlloyDB Omni, we made memory management adaptive. So first of all, the shared buffer parameter can be changed at runtime without having to restart Postgres. And now there's a worker, a job, an agent that looks for the memory pressure, the available system memory, and how much memory would be useful to the instance. If there's extra memory available, it'll make this memory available to the shared buffers. And when it detects that there's memory pressure and the risk of out-of-memory errors, it'll actually reduce the shared buffers and return that memory back to the system, thereby reducing out-of-memory errors or avoiding them altogether and optimizing your performance at any time without any input from you. So that really avoids your toil and it optimizes your database for performance. On another angle, if you look at what is AlloyDB, it's actually 3 databases in one. At the heart of it, AlloyDB Omni and AlloyDB are operational databases that store data in rows, which is optimized for single row lookups of single accounts, single inventory items, or things like that. And it's optimized for high throughput, high transactions. You can update, insert, delete any row at any time. That's what it's optimized for. And so most users use Postgres or AlloyDB or AlloyDB Omni purely as an operational database. However, in the last couple of years, there's also been more demand for real-time insights that require scanning large volumes of data or aggregating data. Typically, you can have this in a separate data store that is optimized not in rows, but in columns, which is really optimized for these types of queries. And you can do this in a separate database. But if you have a separate database for this, now you have to manage 2 databases. You have to set up synchronization between the 2. You have to secure them. It's a lot of extra work and overhead. So that's why we added the columnar engine and the analytic accelerator right into AlloyDB Omni so that you don't have to maintain a second database and worry about how to synchronize the data. And then the other very, very popular recent use case is vector data. There's a number of dedicated vector databases that, again, you can treat just like you would have treated analytical stores in the past. Extract the data from your operational database, load them into a dedicated vector database. But we believe that's work and security risk you shouldn't have to take. You can actually you can store vectors in AlloyDB Omni, and you can query them very efficiently. And I'll go into that in a little bit more detail. First of all, enterprise Gen AI apps is something that many of our customers are looking at building, and they face a number of challenges. First of all, if you think about using a large language model or generative AI in your enterprise, you want to make sure that the information and the answers it gives are accurate and up to date. You also want it to be contextual. For example, if I were to talk to a chatbot from my airline, I wanted to give me information about the flights that I booked, not somebody else. And lastly, when you're building modern generative AI applications, you want them to be enterprise grade, meaning you have the same requirements for security and high availability that you have for all of your other applications. We believe that databases are excellent at bridging this gap between general purpose large language models and enterprise Gen AI apps that are customized to your use case and your customers. First of all, databases already are trusted and hold the most important valuable data of your organization, and that data is also up to date. And databases allow you to efficiently store, query vector embeddings for vector searches, and you can also combine vector searches and similarity searches with traditional relational searches. If you're not familiar with what a vector is, it's really a representation of an object in a multi-dimensional space. In this example on the right side, we have 2 dimensions, and we are plotting objects like cat, dog, table, and others in this 2-dimensional vector space. And even though all 4 of them have 4 legs, or all 3 of these objects have 4 legs, you would expect that cat and dog would kind of end up closer in this vector space. So that if you ask what objects are similar to cat, you would get dog as a result before you get table. And so that's a very trivial use case of what you could use vector search for. In reality, you would have more than 2 dimensions. And vector search and vector embeddings are really, really valuable to get meaning out of unstructured data. Unstructured data could be images, text, sounds, recordings, anything you want. You can send those through an embeddings model that will translate this unstructured data or structured data as well into vector embeddings of hundreds or thousands of dimensions. And if you think about an object that is represented in hundreds or thousands of dimensions, answering the question of which other objects are close to that get kind of mind-boggling, which is why technology and databases are what you want to use to calculate that. And there are serving indexes that will make these types of queries very fast and efficient. And so it'll come at no surprise that AlloyDB Omni includes AlloyDB AI, which really turns AlloyDB into a vector database. First, we added support to generate embeddings right from your database. So you can actually just take structured data, unstructured data like text, and send it to an embeddings model right from the SQL prompt without having to export it, send it to an API, then import it back to the database, make sure it's still current. You can do it right from the database. Second, AlloyDB Omni allows you to store, index, and efficiently query vector embeddings. For example, we added at Cloud Next, we just added support for scan indexes, which stand for scalable approximate nearest neighbors, which is a Google technology that we've been using for over a decade to fast and to efficiently query or index vectors. And lastly, we added support for not just Vertex AI, but also open source frameworks such as LangChain to help you build modern applications really quick and easy. One of the features we launched at Google Cloud Next is model endpoint management. When you think of AlloyDB Omni, which users deploy in their own data centers, you might not want to connect to Vertex AI in the cloud for creating vector embeddings. Model endpoint management allows you to choose which model you want to connect to. It could be Vertex AI, it could be OpenAI, it could be a locally deployed model completely air-gapped from the internet, like a model from Hugging Face or Anthropic. And you can use that to create embeddings and then query these very efficiently in your database. NeuroPace makes medical devices to detect and treat epileptic seizures. They don't just detect and treat them, they also record brain activity in what's called IEEGs from their patients. And they have tens of thousands of these IEEGs available. They created a custom machine learning model to turn these IEEGs, which is basically unstructured data from this perspective, into vector embeddings. And they use AlloyDB AI and AlloyDB Omni to index and query these vector embeddings to find similarities between patients and how they react to treatments, to optimize the next generation of medical devices that NeuroPace builds. Now, if you want to get started and try out AlloyDB Omni, we try to make it as simple as we could. We packaged AlloyDB Omni into a single container image that you can download from Docker Hub and run with a single command. We also made it compatible from a command line perspective with Postgres' official image that they publish on Docker Hub, so that if you're already using a container-based development flow for CI/CD, you can easily swap out the Postgres image for the Google AlloyDB Omni image. We compile and run on both Linux and Mac, both on Intel and ARM architectures. And I want to call out that AlloyDB Omni comes with the developer edition that is free to use for development and evaluation. The developer edition has no limits on features or data size, so you can try out everything that AlloyDB Omni has to offer on any size of data. And once you're moving this application to production, you can upgrade to a supported subscription at any time. In addition to these standalone Docker-based deployments, VMware Data Services Manager automates the provisioning and the lifecycle management of AlloyDB Omni on VMware Cloud Foundation. And if you're running Kubernetes, our Kubernetes operator for AlloyDB Omni automates not just the provisioning, but also lifecycle management through a declarative API, and it abstracts all the management of Kubernetes for you. Many DBAs and database professionals that I talk to are interested in Kubernetes, but they might not be experts in how to create pods, stateful sets, load balancers, and all of these things in Kubernetes. And so the good news is our operator abstracts that for you. You just declare what you want a certain deployment to look like, how many standby databases you want, and the operator will not just implement that for you, but also make sure it stays there. And then obviously we automated things like backups, restore, provisioning, scaling up, down, patching, and so on. We had this operator available in preview since late 2023, and we just launched it into general availability at Cloud Next in April 2024. And with that, I want to wrap it up. If you want to learn more, or I want to encourage you to learn more, go install and explore what AlloyDB has to offer. There's a QR code that you can scan or a URL that you can navigate to, which will take you to our product page, to our documentation, to labs and examples. If you remember only 3 things from today, it's A, AlloyDB Omni scales further with more CPUs and allows you to run SQL queries fast in open source Postgres. We made operations such as memory tuning, vacuuming much easier and toil-free with autopilots. And we have great capabilities that allow you to build amazing generative AI applications in AlloyDB Omni. If you want to learn more, please reach out to us and contact us either through your Google Cloud Platform account team or by emailing alloydbomninotice@google.com. And with that, I want to thank you for your attention and wish you a happy and great rest of your day. Thank you.